As will be shown, momentum effect of massive moving parts is not the same on a 1/32nd scale model. The wooden frame of this engine was made of yellow pine, well jointed and bolted together. It was built in 1839. Steel frames only appeared 50 years later. I will combine steel and wood. Huge bed timbers and large knees of oak supported the crankshaft pillow block, which was held down with tie rods and 4 2-inch bolts. Part of the engineer's work was to watch for signs of looseness of the frame structure and tighten tie rod nuts and turnbuckles when necessary. Obviously, it was named A-frame. Walking beams were usually made of a heavy iron skeleton casting with the trunnion and 2 short and 2 long projecting arms. A huge diamond-shaped wrought iron band was heated and pressed over it. This walking beam was also stiffened with the diagonal bracing. Smaller engines usually didn't need one. those of you interested, this cylinder and valve chest are shown in detail in part 2. A large boat spacer ensured top alignment of the 14 feet tall crosshead guides. It also served as a nameplate display for the Phoenix foundry. The two huge crank arms were keyed and pressed onto the inboard ends of both paddle wheel shafts. That made it a 50 feet long shaft. My paddle wheel shafts will be made separately. These marine walking beam engines were gigantic. While maneuvering and engine coming almost at a standstill, engineers relied on the effect of this enormous mass of moving parts. It would carry the crank way past top or bottom dead center points. Unfortunately, this momentum effect won't happen on a small model. Engine will stay stuck right there. Of course, I cannot allow that to happen on a radio-controlled model ship. So to keep things simple, I made this small wobbler. Mounted at 90 degrees, it will bump the crank over. So now let's see if it works. Some adjustments needed, but quite good. Still the pump and reversing valve to make needs to be painted, and next time I will be running it under steam. Thanks for watching.